Currently, a particular shrub thrives along roadways from Maine to Georgia. Its small, crimson berries boast 17 times the lycopene found in tomatoes and a higher antioxidant content than blueberries. This plant remarkably extracts nitrogen from the atmosphere, transforming it into a perpetually available, free fertilizer. It requires no irrigation, no pesticides, and absolutely no upkeep. A single specimen can yield up to 8 pounds of fruit annually. Yet, in Ohio, Massachusetts, and an expanding roster of states, its sale is now prohibited. The government once invested decades in distributing millions of these plants across America. They compensated farmers for cultivating it and supplied seedlings from state-run nurseries. It was hailed as a miracle solution for depleted land. Then, in 2023, vending it became a felony. This is the autumn olive, or Elaeagnus umbellata, and the endeavor to eradicate it exposes the consequences when a natural food source imperils the financial interests tied to chemical dependency. Welcome to Nature Hidden Beneath. If these narratives resonate with you, subscribe now and share in the comments which forbidden botanical you'd like us to investigate next. Ring the bell so you never overlook what they attempted to make us forget. The historical record commences in the remote Himalayan villages. For millennia, communities residing at altitudes exceeding 2,000 meters recognized this plant by its silvery foliage. In China, Korea, and Japan, these berries were not perceived as a nuisance, but as a remedy. Traditional healers utilized the fruit to address liver ailments and digestive complaints. They brewed infusions from its blossoms to bolster cardiovascular well-being, prepared seeds for respiratory conditions, and extracted oil from the fruit to alleviate inflammation. In challenging mountainous terrains, where temperatures fluctuate widely from 43 to 55 degrees Celsius, where the soil is rocky and precipitation unpredictable, this plant endured when others failed. It flourishes in a pH range from 5.5 to 9.5, tolerates drought, pollution, and impoverished soil. It demands nothing, yet provides abundantly. Envision an elderly woman in a secluded Himalayan village. The rice harvest has failed, the wheat is scant. Along the periphery of the terraced fields, silverberry shrubs are laden with scarlet fruit. She gathers them by the handful, ensuring her family's survival for another season. For 2 millennia, this was not viewed as a weed. It was a safeguard against famine. Then, in 2001, modern scientific inquiry converged with ancient knowledge. At the USDA Agricultural Research Service facility in Beltsville, Maryland, a horticulturist named Ingrid Forum sampled the berries during routine fieldwork. She noted their intense red pigmentation. Her colleague, Beverly Kalevans, who directed the phytonutrients laboratory, offered to analyze them for carotenoids. Their findings astonished the research team. The berries contained between 15 and 54 milligrams of lycopene per 100 grams of fresh fruit. In contrast, raw tomatoes typically contain about 3 milligrams per 100 grams. Autumn olive berries exhibited up to 17 times higher concentrations. Forum later recounted their amazement at the discovery. Lycopene is the compound responsible for the red hue of tomatoes, and is also one of the most potent antioxidants known to science. Researchers have correlated it with a reduced risk of prostate cancer, lower incidences of heart disease, and protection against cellular damage. In the United States, 80 to 90% of lycopene intake originates from tomatoes and tomato products. Yet, here was a wild shrub yielding concentrations that no commercially cultivated tomato could equal. The breakthroughs continued. In 2019, Korean researchers published a study in Nutrition Research and Practice. They administered autumn olive berry extract to diabetic mice. The results indicated that the berries lowered both fasting and postprandial blood glucose levels. The extract demonstrated 92% of acarbose's effectiveness in inhibiting alpha-glucosidase, the enzyme that catabolizes carbohydrates into sugar. Acarbose is a pharmaceutical agent prescribed for type 2 diabetes, a wild berry rivaling the efficacy of a prescription drug. In 2020, Italian researchers at the University of Turin performed a phytochemical analysis of the fruit. They identified a total polyphenolic content of 325 milligrams per 100 grams and an anthocyanin content of nearly 195 milligrams per 100 grams. These figures are comparable to those found in blueberries, raspberries, and cherries. The berries also contain vitamins A, C, and E, essential fatty acids, flavonoids, and minerals including potassium, calcium, and magnesium. A 2012 study by Katak, published in the Journal of Medicinal Plants Research, reported 27.8 milligrams of vitamin C per 100 grams. Pakistani researchers have documented hepatoprotective effects, indicating that the fruit safeguards the liver and kidneys and combats oxidative stress at a cellular level. These are not anecdotal folk remedies from ancient herbals. These are peer-reviewed studies published in reputable scientific journals. The USDA confirmed these findings. Universities across 3 continents corroborated them. The most concentrated source of lycopene in the temperate world was flourishing natively along American roadways. However, the berries represent only half the narrative. Beneath the surface, something even more significant was occurring. Autumn olive belongs to a category known as actinorhizal plants. Its roots establish a symbiotic relationship with bacteria called frankia. These bacteria reside in specialized nodules on the root system, where they perform nitrogen fixation, drawing atmospheric nitrogen gas and converting it into ammonia. This is the identical form of nitrogen found in synthetic fertilizers, like ammonium nitrate, with the distinction that this plant generates it freely and indefinitely. In 1989, researchers led by Peshka investigated autumn olive intercropped with black walnut trees. They estimated that the shrubs contributed as much as 90 kilograms of nitrogen per hectare annually. This translates to approximately 80 pounds per acre each year, requiring no input whatsoever. Now consider the economic implications. Synthetic nitrogen fertilizer costs approximately 60 cents per pound at current wholesale prices. 80 pounds multiplied by 60 cents per pound equates to $48 per acre in annual free fertilizer. Extrapolate this across the millions of acres of degraded agricultural land, abandoned mine sites, and eroding hillsides throughout America. We are contemplating billions of dollars in fertilizer that farmers would never need to purchase. Billions of dollars that chemical corporations would never accrue. A farmer in Ohio surveys his depleted cornfield. The topsoil is thin, and yields are declining. He confronts 2 options. He can continuously acquire bags of synthetic nitrogen every spring, year after year, indefinitely. Or he can cultivate a shrub that fabricates its own nitrogen from atmospheric air, produces an edible superfruit, and demands 0 maintenance. The chemical industry holds a very strong opinion regarding his choice. Here the story takes a turn. Autumn olive was introduced to America in 1830. It was initially brought as an ornamental plant, valued for its silvery foliage and aromatic blossoms. For over a century, it remained sparsely distributed in gardens and arboretums. Then, the Dust Bowl struck. In the 1930s, decades of aggressive plowing had divested the Great Plains of native prairie grasses. When drought ensued, nothing remained to retain the soil. Winds lifted millions of tons of topsoil into the atmosphere, and black blizzards buried farms from Texas to the Dakotas. Families migrated westward in desperate convoys. In 1935, Congress established the Soil Conservation Service, whose mandate was to prevent America from succumbing to erosion. Researchers began evaluating plants that could rapidly stabilize soil. They required species characterized by swift growth, tolerance to adverse conditions, and minimal maintenance. In the 1940s, the Soil Conservation Service commenced studying autumn olive. It successfully met every criterion. By the 1950s, state and federal agencies actively championed it. They planted it along highways stretching from Pennsylvania to Illinois, utilized it for land reclamation in Appalachia's strip mines, and established it on dam embankments and reservoir edges. In 1963, the USDA officially released a cultivar named Cardinal for commercial propagation. Imagine a government agent in 1960 driving a pickup truck down a rural road in West Virginia. The truck bed contains hundreds of autumn olive seedlings. He stops at farms along the route, distributing them to landowners. "Plant these on your eroded hillsides," he advises them. "They will prevent soil runoff, nourish deer and songbirds, and enhance your land." And he was correct. The plants fulfilled their promise precisely. They stabilized eroding slopes, provided sustenance for wildlife throughout winter, and improved degraded soil with their nitrogen-fixing roots. They necessitated no irrigation, no fertilizer, and no maintenance. They propagated autonomously as birds consumed the fruit and dispersed seeds across the landscape. They succeeded far beyond anyone's expectations. And that triumph became their detriment. By the 2000s, the very attributes that once rendered autumn olive valuable were reclassified as threats. Fast-growing became aggressive. Hardy became invasive. Self-spreading became uncontrollable. In 2006, Massachusetts designated it an invasive species, prohibiting its sale and propagation. Other states followed suit. In 2018, Ohio enacted regulations banning the sale of 38 invasive plant species, with autumn olive included on the list. After a 5-year grandfathering period, the ban fully commenced on January 1, 2023. South Carolina added 3 species of Elaeagnus to its state plant pest list. In 2024, the USDA Forest Service now categorizes it as a Category 1 invasive species, forbidding it on all National Forest System lands. Multiple states impose restrictions on its transportation and sale. It is now illegal to import at the federal level. The official justification is that it outcompetes native plants, alters soil chemistry, and spreads uncontrollably through avian dispersal. Consider the true implications of these grievances. It outcompetes native plants because it produces free nitrogen, a capability native plants cannot match. It changes soil chemistry by rendering the soil more fertile. It spreads uncontrollably because wildlife consume its nutritious fruit and deposit seeds in their droppings. This particular plant evolved to perform these very functions. Governmental bodies specifically chose it because of these capabilities. Now, engaging in these activities is deemed illicit. Follow the financial trail. When autumn olive encroaches upon a location, land managers receive instructions to eradicate it. The recommended eradication methods entail repeated applications of glyphosate and triclopyr. These herbicides are products of chemical manufacturers. A landowner in Indiana observes autumn olive proliferating across her 40 acres. She contacts the county extension office, which informs her of its invasive nature and the necessity of herbicide application. They provide a list of approved contractors. She expends hundreds of dollars per acre for chemical treatment. The subsequent year, she incurs the cost again due to root resprouts. She continues to pay repeatedly. Herbicide manufacturers accrue revenue from each application. Native plant nurseries offer her approved replacement species. Furthermore, control contractors submit invoices for their labor. Everyone profits except the landowner. The land itself loses a plant that fixes nitrogen, nourishes wildlife, and prevents erosion, all without requiring financial outlay or authorization to cultivate. This pattern is a familiar one. A plant that offers inherent advantages is systematically eradicated. In its stead, we implement systems that necessitate continuous expenditures. White clover was omitted from lawn seed mixtures so that companies could market nitrogen fertilizers and broadleaf herbicides. Perennial grains were supplanted by annuals, compelling farmers to purchase new seeds annually. Mesquite forests were razed for cattle ranching, an activity that degraded the very land the trees had previously conserved.
Autumn olive represents the most recent chapter in a long-standing narrative. That which cannot be owned cannot be sold. That which cannot be sold must be criminalized. However, a shift is occurring. Throughout Appalachia and the Midwest, foragers are rediscovering the bounty along their thoroughfares. They gather the berries in autumn. As the fruit transitions from silver to a deep red hue, they craft jams and jellies. They dehydrate the berries for tea, press and process them into fruit leather, a favorite among children, and ferment them into wine. The taste is both sweet and tart when the fruit reaches full ripeness, and its astringency diminishes as sugars develop. Each berry contains a single seed, which can be ingested or expelled. A family in rural Pennsylvania fills buckets in a single afternoon from shrubs growing on a disused mining site. They process the berries in their kitchen and store jars of deep red jam in their pantry. They have preserved what is arguably the most concentrated source of lycopene available in temperate climates. They incurred no cost, sought no permission, and violated no law because they harvested the fruit without selling it. Permaculture practitioners are challenging the invasive designation. They emphasize that native ecosystems are largely absent across much of the eastern United States. They question whether a nitrogen-fixing shrub that sustains wildlife and stabilizes soil is genuinely more detrimental than a chemically treated lawn. They inquire who benefits from the distinction between native and invasive species. They ask why a plant is labeled invasive when it thrives independently of human intervention, whereas native species requiring constant management and expense are deemed desirable. Climate change is intensifying, resulting in more frequent droughts. Soils are increasingly degraded. The industrial food system relies on synthetic nitrogen produced using fossil fuels, rendering this system vulnerable. Autumn olive is unaffected by supply chain disruptions. It does not require natural gas to fix nitrogen. It does not necessitate irrigation during periods of drought. It patiently endures in hedgerows and along highway margins, yielding fruit year after year. It enhances the soil it grows in. It sustained Himalayan villages during periods of famine. It could potentially nourish American families through whatever challenges lie ahead. This holds true if we cease poisoning it, cease criminalizing it, and recall what the government understood in 1950 but chose to disregard by 2023. When you observe those crimson berries gleaming in the autumn sun along a rural road, grasp their significance. You're witnessing free lycopene at 17 times the concentration found in tomatoes. You are observing free nitrogen extracted from the atmosphere. You are seeing wildlife habitat in a landscape stripped of biodiversity. You are witnessing drought resilience in an era of climatic instability. And you are seeing a plant that your government spent decades cultivating, endorsing, and distributing before deciding it was overly effective. The fundamental question is not whether autumn olive possesses utility. Scientific consensus affirmed that decades ago. Instead, the question is, who dictates what you are permitted to cultivate on your own property?